Welcome to the fourth part of our exponents and surds revision. This is a technology-free test. You can't have a calculator, so we're going to have to use some cunning mathematics in order to solve this. Now, if I look at the first one here, I'm going to look at the power. The denominator of the power is 3. What I want to do is I want to see if something to the power of 3 is equal to 8. So if I have my cubes, list of cubes, 1 cubed is equal to 1, 2 cubed is equal to 8. Oh, that's convenient. So I'm going to rewrite this first question. Instead of 8, I'm going to write it as 2 to the power of 3. And then it's still going to have the same power here of -1/3. Now, remembering our index laws, if we have a bracket we will multiply the powers through. So 3 times a third is 1, 3 times a negative a third is -1. So we're going to have 2 to the power of -1. And then with the negative power we need to invert that, so that becomes 1/2. And that's our exact answer. So 8 to the power of -1/3 is equal to 1/2. Now if we go on with the second example, we have to do the same thing. Luckily for us it's the same number, so we've got 3 as the denominator of our power. So I'm going to rewrite the 8 as 2 to the power of 3. That 3 looks pretty ugly, doesn't it? And we'll have the power of 4/3 out here. So remembering our index laws, so this is going to be 3 times 4/3. The 3 will cancel that 3. It will give us 2 to the power of 4, which is equal to 16. And that's our answer here. Let's move on to the next one. Simplify. Okay, if we have something like this, whatever is outside the surd gets multiplied together, so this will be equal to 3 times 4, and then whatever is inside the surd gets multiplied together, so 7 times 5. So this will be equal to 12 square root 35. Now I need to look at that 35. Is there any perfect squares that go into 35? No, there's not, so that's going to stay as our answer. For the next question, we need to collect our like terms, so we've got root 7 and root 7. So we have 5 root 7 plus 2 root 7 is equal to 7 root 7. And then we have the root 11 terms, so we've got -3 root 11 plus 5 root 11 would be equal to -3 plus 5 is plus 2. And that becomes our answer. If you see things like this, it might be easier to think of them in terms of an algebraic expression, funnily enough. Instead of the root 7's, I'll write a, so it could be 5a plus 2a. And instead of root 11, I'll write root b. Instead of root 11, I'll write b. So take away 3b plus 5b. You would have seen these probably year 7, maybe even year 6. So simplifying these algebraic expressions, 5a plus 2a is 7a, minus 3b plus 5b is -2b. And you should notice that the 7 and the 7 is the same, and the -2, it should be plus 2, isn't it? It's going to be the same there, so -3 plus 5 is plus 2. Okay, let's move on to the next one. And for this one here, we'll need to expand out the bracket. So this is going to be 6 root 3 times by 1 plus 6 root 3 times by 2 root 5. So this will be equal to 6 root 3 times 1 is just 6 root 3. Plus, now for this one, like the last question, if it's outside the surd, we keep it outside the surd, so 6 times 2 is 12. And then inside the surd we're going to have 3 times 5 is 15. Now if we look at the two surds that we have, there's no way that we can simplify them. They are very different surds, so we can't add them or subtract them or anything, so that becomes our final answer. So just remember with questions like that, that if it's outside the surd, it's outside the surd, so we have 6 times 2 becomes 12, and the 3 times 5 becomes the 15. So on to the next question. We need to look for any surds that are like surds, so they're the same surd. So there's 6 and there's 2, 24 we'll have to simplify, and 8 we'll have to simplify. So this will be equal to 7 root 6, I'm just writing it out again, take 2 root 2, plus perfect square that goes into 24 is 4. So this will be 4 times 6 plus, and similarly 4 goes into that one, so that's going to be 4 times 2. So this will be equal to 7 root 6, take 2 root 2, plus the square root of 4 is 2. So the 2 comes outside the surd and we leave 6 inside, plus again here the square root of 4 is 2, root 2. I'll just draw some little arrows to represent what's happening there. So the square root of 4 becomes that 2, and the square root of 4 here becomes that 2. And this root 6 will stay as root 6, that root 2 will stay as that root 2. So now we have some like surds. So we've got root 6 here and root 6 here. I'll just rewrite this in order. So 7 root 6, keep the plus that's in front of the root 6 with it, so plus 2 root 6. And then we have take away 2 root 2, so keep that take away with it. Take away 2 root 2. And then the last one we have is plus 2 root 2. And our final answer will become 7 root 6 plus 2 root 6 is going to be 9 root 6. Plus 2 root 2, take away 2 root 2 will actually cancel each other out, so that becomes 0, that last part. So we end up with 9 root 6, and that's the end of this one.